Welcome back, it's the Hawaiian Shirt Coder here again, and we're continuing on our series to do with web APIs. Now we've got to the stage that we want to connect our SQL database to our web API code. This is known as data access. So we're going to create our data access layer right here, right now. So here we go with our data access layer. Just a heads up before we get started, this video is probably the most complex so far in terms of concepts, but don't worry about that too much. The key thing to take away from this is at the end of this session we'll have a selection of code that's responsibility is to purely talk to our underlying SQL database. That is its job. How it's implemented isn't particularly important for the whole context of the web API series. Databases are a complex topic and probably deserve their own series in their own right. So the takeaway from this is creating a series of code that is responsible for issuing the various SQL statements to the database in order to get the correct responses back. So at the moment this is our current system, and if you've been following on through all the other videos, you know that we've done lots of different things now. We've created data validations, we created DTOs and the mappings of those DTOs to actual underlying model objects. All the way along we've been using an in-memory database to take away some of the complexity. We've also done an independent video that actually set up a proper database, a SQL Express database in our case. But at the moment this SQL Express database is not connected in any way to our web API. Our web API does not know how to issue commands to it and receive results back from it. So this is another improvement opportunity. And this improvement opportunity I've called creating a data access level with data access code. So the data access level is all the area on the diagram highlighted in this light green, and its purpose is to provide a separation of concerns in the system. So all the code in the data access layer has one responsibility, and that is to handle all database transactions or queries. So like I said, that is the area that will deal with how to select data from the database, insert data from the database, delete data from the database, and update data from the database. By introducing this data access layer, our web API will have a connection to a piece of infrastructure, a SQL database, where all our data can be persisted, which will overcome one of our problems with our in-memory database, that as soon as you stop the web API, any changes that you've made that have been saved to the in-memory database are lost. This won't be the case by having a proper database. So by the end of this session, we'll be in a much stronger position to actually get rid of the in-memory database altogether. Just for clarity, you may use the term data access layer or DAL interchangeably throughout this video. They are the same thing. They are the level of code that talks to the database. So the learning outcomes in this session are as follows. Even though databases is a huge subject and database access is a huge subject, I thought it would still be beneficial to do a little bit of theory. So a brief discussion of various ways we can talk to a database with our C# code. But the main goal, if you take nothing else away from this session, is to create a code base that deals with data access, a data access layer. So main goal, get the Web API to be able to communicate with our SQL Express database to perform CRUD, that's create, read, update and delete operations against the database, i.e. we're going to create the DAO. And finally, because there will be some complex concepts in this session that you don't fully need to understand, but it would be nice at the end of it that we can actually test out all the code that we've written to see if it works. So we'll be testing the data access layer, or DAO, out against a dummy application, not our web API, just a console app that will let us perform various calls to our data access layer to be able to get player information in and out of the system. So let's get straight into some of the theory in this video. Connect into a database with C#. So the old way is to use a technology that is built into the .NET framework called ADO.NET. ADO.NET is how I would describe very close to the metal, so it's you have to do quite a bit of plumbing in order to get all the various bits to work in order to talk to the database. The various bits that make up ADO are, you need to know and specify the connections that are involved to get to your database, the commands, which is in essence the queries and execute commands that you want to fire to your database, the parameter objects that are required in order to add extra information to your commands, and then how you want to receive any data back. These can be through data readers, data sets and data tables. The one thing you'll notice with this old method, which is still perfectly valid to use, and lots of the other technologies build on top of the ADO, but add a level of abstraction, is that it is very verbose to write, and you end up writing a lot of code for doing the same sorts of thing. And it's also not a perfect match, because ADO.NET is more concerned, or sits on the side more of the database, so you can tell that by some of the objects that you create, data sets and data tables. Well, data tables is a representation of a SQL database table. It's not really a very perfect match for object-orientated programming. This is often known as the impedance mismatch. And I just want to skip over quickly to an example of what ADO code looks like. And you can see that this piece of ADO code, which is just doing a select statement, passing in a parameter of price point, uses quite a bit of code in order to produce that result, and you would have to do this each time for each piece of code. So we have a connection string up the top, we'll talk more about those later, the actual SQL statement we want to issue to the database, the parameter value we want to pass into the SQL statement. Then the first thing we have to do is go off and make a connection through an SQL connection object. Then we have to create an SQL command object. Then we have to add an SQL parameters object if one is required to the SQL command. Then we finally have to open the connection and execute the command into a thing that will handle the data coming back, which is an SQL reader. And then once we've got the reader, we can loop through the reader, which is a forward-only reader, while the connection is still open to get the results out. And finally we close the reader, and then finally at the end we will close the connection, which will all get catered for in this using statement. So you can see there's quite a lot of stuff going on there, and like I said, it's quite verbose. That's quite a few lines of code. So if we continue on with our slides, so this is the nearest to the metal way of doing things. You don't often see it done this way these days. So let's move on to our next slide. So continuing on with our theory, these days common to see a further level of abstraction between the database, rather than talking almost a one-on-one to ADO.NET. We have a level of abstraction that sits on top of that, and that level of abstraction is quite common to be a object relational mapper, or ORM. Its job partly is to overcome this impedance mismatch that you have and make our database access code in a more object-orientated style, as we are using an object-orientated language. So it sort of has a clue in its name. It will take C# objects, so for example a player object, and it will map it to a relational representation of that data in a database, so a player table. So it will handle that mapping for you in the background through an abstraction that you don't have to worry about. So this makes our programming a lot less verbose and also a lot more intuitive, because it will use the simple sort of object dot notation that we're used to. So player dot and first name will appear, player dot last name will appear. So there are several object relational mappers available, and like I said, object relational mappers is a large subject and again could be its own series in its own right. So that's as far as I want to go with saying what they are and the theory of them. There is a lot more information to learn about object relational mappers, but to stick to the goal of getting a web API that uses the database, we are going to use an object relational mapper. So I thought it would be worth mentioning some of the object relational mappers that are available. So probably the most well-known one, certainly in the Microsoft sphere, is Entity Framework, which is devised by Microsoft itself, and it is a full-blown object relational mapper dealing with all the object relations, all the context, knowing what state each of the objects is in, and dealing with all the relationships. And it allows you to communicate with your underlying database through doing link queries, and those link queries get converted in the background, invisible to the coder, into actual SQL statements that get issued against the database. Another one that's been around for a long time is nhibernate, that works sort of on the similar sort of premise as well. It's sort of got ported from nhibernate, which was a Java object relational mapper, into nhibernate, where the N stands for .NET. And it is also a full-blown mapper as well. Needs a little bit more configuration than Entity Framework, but that is one that you will also see out in the ecosystem. But finally, there's one called Dapper. I'm not saying this is an exhaustive list, there's several other ORMs, but these are three of the most common ones. And Dapper is what's known as a micro ORM, and that's the one we'll be using for creating our data access layer. So Dapper, what is it? Let's tell you a little bit more about Dapper. So, like I said, ORMs are complex subjects. So we want something for our purposes to fit our use case of creating our web API and learning about web API rather than database access layer technologies and databases. It is as simple as possible to use. So Dapper is lightweight, or a micro ORM. So it fits perfectly with what we want to do. It's quite quick, quite easy, but still quite powerful, and also allows us not to have to write too much code, unlike ADO.NET. And what it does, unlike Entity Framework, is it doesn't use LINQ to produce its queries. You write the queries in SQL. So SQL is the best thing for querying relational database. So Dapper has said we'll use SQL because it's good at doing that. Dapper written by Stack Overflow, and you'll see when we come to download it in the actual practical session of creating our data access layer, it's had millions and millions of downloads. So it's a well used, stable, third-party NuGet package. And I've also left a couple of resources that you can go away and have a look a little bit further on some of the things you can do with Dapper. So let's finally start trying to get rid of this in-memory database and build a data access layer that will talk to our SQL Express database. So what we need to do first of all is go into the SMS shared folder, and then in the DAL folder that we created earlier on in the series, we're going to start to add a file or some files to implement our data access layer. And we're going to implement our data access layer with a micro ORM, object relational mapper, known as Dapper. Now, even though this series is not about databases and access to databases, because this is such a fundamental part of our improvement and the infrastructure, I am going to spend some time on this video going through how we're building up our data access layer. There'll be quite a lot of code, so please feel free to pause the video and take stock of what we've done at certain points. Because there's a lot of code, I would like, if there's time as well, to just produce a demo program that utilizes our data access layer just to prove that it actually works, as otherwise we're going to write a lot of code this video, not actually see it in action until it's fully wired up into our web API. So just to give us a little bit of confidence that our data access layer is talking to the database, if time allows, I'm going to create a little console application that's just going to make use of that new data access layer. Right, so first things first, we need to create our data access layer using Dapper. So this means we need to go off and get some third-party dependencies. Up until this point, we haven't really had to use any NuGet packages, but now we're introducing infrastructure, i.e. a database. We need some third-party packages to help us do that. To hook our C# web API code to our underlying database store. So in the shared folder, if we right click on dependencies and go manage NuGet packages, ensure you've got the browse option selected, and then the first package we need 3 in total, is Dapper itself. So let's type that in. And here we go, and it's the very top one, and you can see Dapper's very popular. At the time of writing, it's had 195 million downloads. So we select that one. So we don't keep getting these error messages at the bottom that are false. In our case, to do with our database, I'm just going to unload the database project here. So that's good, and we can go back to our shared library. What I'm going to do is actually click on the csproj file, and you can see, we can tell when the NuGet package got added, because it'll get added to this area here, the item group. So the other package that we need is this one. So if I right click again, go NuGet packages, and this time I'm going to search for Microsoft dot data, extensions dot configuration dot abstractions, which is the top one. We're going to bring this one in. Now this NuGet package helps us with our wire up of our data access layer. It lets us have access to our configuration settings, which we'll need in order to obtain the connection string to our database will be stored in our configuration settings. So not directly related to databases per se, but a way of accessing secrets and configurations in our system. So we need that one. And then one final one. Let's just, before we add that one in, just check it's been added. There we go. One final one we need is we need system.data.SQL client. And this is the provider that says this is how you speak to a SQL Server database or a SQL Express database. There's several other clients you can have as well, for example Postgres or SQLite or even Oracle, but in our case this is the one we need. Again, a lot of downloads, 472 million. And we accept everything there, and then if we go back to here, you will see that that is added in all of our packages. At this point as well, it might be worth going back to the NuGet package manager and just check that it's not expecting any updates for anything else that's installed, which it doesn't, so that's all great. So we can close that down and we can rebuild that project. And at this stage we wouldn't expect any errors and we don't get any, so that's good. So we can actually start using these third-party libraries now to utilize Dapper to act as our data access layer, to be able to throw queries at our SQL database to get data, update data, delete data, and insert data. So if we go back to our data access layer, go right click, and we're going to add a brand new class. And this class I'm going to call Dapper Data Access. Just switch out the namespace, make this public. I'm going to remove all these using statements that come in by default, and I'm going to add in the following using statements, which are all to do with the new NuGet packages that we added in. So we funny enough need to use Dapper. We've got the configuration extensions, which we may or may not use in here, so this one may disappear. We have got access to the system.data and the system.data.SQL client, so it knows we can talk to SQL Express or SQL Server. Right, so what our data access layer will do is it will be generic, so it will let you perform any sort of select statement for getting data out the system, known as a query most of the time, and it will perform any sort of command that issues a command at the database. So commands are normally inserting new data into the database, updating data, or deleting data. So those are the two methods that we're going to create in this section that will handle any query that we throw at it. So let's go ahead and do that. So the first one I'm going to do is a query for getting data, which in SQL speak is any sort of select statement. And like I said before, there is almost a one-to-one mapping with database CRUD operations and HTTP verbs. So select in SQL maps directly back to any of our API requests that our HTTP gets. So this is what this method will cater for, is whenever we're doing any sort of get operation, this generic query should be able, or generic method should be able to handle this. So let's just lift a piece of code and walk you through it. So here is a method signature. We won't worry about the fact that it is asynchronous at this stage. We can go into that later. All you need to know is it is using generics. So this means we can pass any generic type into this here. And what it will return back is an IEnumerable, a list of any particular type. So these will be, in this T, will be our models in our database. So give me a list of players, or give me a list of fixtures, or give me a list of availabilities. So I'm going to call this statement run a query. So this is doing any sort of select based activities. And in order to do that, we're going to pass in these parameters. We're going to pass in a string parameter that is our SQL statement. So the actual SQL we're going to fire at the database. We're going to pass in U parameters. So this basically lets us pass in anything that we like, but these will be the parameters that may be required for the SQL statement. So for example, when you go and get a player by its ID, one of its parameters is ID that gets passed into the query. We'll write some examples of potential queries that we might use in a minute as comments, just to make that more clear. The command type is the types that Dapper will allow you to issue as some sort of query. So I've set this to use the command type default if it's not provided as text, which will mean you'll be able to provide a SQL statement. Other ones include stored procedures, which may be something we might add in a later video, but that's finessing the solution, so we'll do that later. And the final thing is a connection. I'm going to change this slightly. I'm going to make this a connection string. And I'm going to, we will leave that as SMS for now. So in order to connect to any database, your code needs to know the connection string. The connection string typically is a thing that would go in your configuration settings that we haven't sorted out yet, but it will detail all the credentials you need in order to access your database. So it will say what server it's on, what's the name of the database, who the user is, what their password is, and other parameters you can pass to as well, such as timeouts and whatnot. So that's what this will handle. So now we need to actually start writing some implementation of a query. So just to give you some demonstrations of what this particular method will be able to achieve, is it will let you do things like this. select everything from the player table, or select everything from the fixture table, or select everything from the player table where the ID is a value passed in. So for example, if we pass in ID 1 in our database up to now, in our in-memory database, 1 has always been John Smith. And it can also do far more complicated things like selecting across multiple tables. So this would come into effect when we're trying to do some of the endpoints that relate back to the availability section. So sort of one where it says give me all the players available for a given fixture. That's a different sort of select statement. That is a select statement across 3 tables. It's a 3-table join, which I'm not actually going to write here and now. So the key thing to take away is this method deals with select, and it will deal with any select. So it's nice and generic. So we only have to write this once, and then we pass in the statements we want to throw at it with any parameters, and we can override the command type if we like, and we can also override the connection string type if we don't supply it, if we supply one, and in turn that will return back a type in a list, which is basically the results list, because selects always return results. Even if that result list has nothing in it, it is a result list. So let's just implement this now. And why I've chosen Dapper is it is quite lightweight and doesn't involve much code. So I'm just going to copy in the lines of code, in fact the 2 lines of code that it needs. So here's the first line. And the second line is this. So let's just walk through these. So the first line is saying I'm going to use an interface DB connection. So this is actually setting up the connection, opening the connection to the database from our code. And it's creating a new SQL connection, and what a SQL connection needs is a connection string, which is the parameter that we're going to pass in. And at the moment I'm just going to leave it like that. So when we implement this, I'm not going to pass in SMS, I am going to pass in the connection string, but later on I'll tidy this up, that if you don't pass anything in, this method will be intelligent enough to go away and try and find a connection string that is called SMS. So that's all we need on that line. That creates a connection. The important thing to note here is it's in the using statement. So what this will do, because connections to third-party resources such as databases are expensive calls, this will make sure that it frees up resources as soon as we've finished with issuing our query and talking to the database. So this using statement is very important. And in older code bases or older versions of C#, it used to be using and it had to be wrapped in brackets, but we don't need to do that now. So what this does is this implements iDisposable in the background and cleans up our resources, which is good. So again, that's being a good citizen. Then the next bit is actually where it will issue the query at the database. So it says return await, which is asynchronous, the connection, and it's running a query asynchronously. It's going to return a certain type, which will match this type up here, based on the SQL statement that we pass in, any parameters that are needed, and also the command type. So what it's going to say is execute this query against the database. If it's got any parameters, also slot those into the query, query it, wait for a result, and then return the result, which it will always assume is an IEnumerable or list of the type that you specified in the position T. So like I said, player fixture availability. That's all we need for doing select statements. So now we need to write another method in here that will deal with inserting, updating, and deleting data. And again, these map almost one-to-one to our HTTP verbs. So an insert statement in SQL maps to a HTTP post in our web API. An update maps to a HTTP put or a HTTP patch, and a delete maps to a HTTP delete. So let's just copy in the method signature for this one and walk you through this. It looks very similar to the one above. So it looks like this. Again, I'm going to change this to connection string rather than connection ID. So if we just walk through this one, this is going to execute a command. Again, it's using a generic of T. And we're going to provide it with a SQL statement, which I'll give some examples as comments in a moment. And the SQL statement may or may not have any parameters. And we can also specify what sort of command type we're firing at the database. Again, by default, if we don't supply that, it will assume it is a SQL string. Otherwise, it could be a stored procedure. And also, we're going to specify how we connect to the database, just like we did up here with a connection string. And even though we didn't implement it above, if we don't supply one, it will use the connection string of SMS. But we haven't written that logic into our code yet, so we can come back to that. I just want to get this up and running nice and quickly, and then we can finesse it later on. So based on that, let's write our implementation. And our implementation, again, another beauty of Dapper, like I said earlier, is that it is very succinct. So this again only has 2 lines of code, and I shall write the first one, which will look very similar to what you've seen already, is making a connection to the underlying database. So again, it's using a using statement, so it will dispose of the connection that is made, the open connection to the database once everything is complete. And it is using the SQL connection, which is part of this namespace. So this SQL connection is optimized to perform specifically for SQL Server. That's why you pull in specific ones, so they're more performant. So there'll be one for SQLite, Postgres, Oracle, and so on. Then the important line comes next, the bit that actually will issue the insert, update, or delete statement against the database. Now these statements are executions rather than queries. Their job is to execute a command against the database and not necessarily return any data. When you, which makes sense because when you're issuing a delete, you wouldn't expect to get data back. You're trying to remove data from the database. When you insert data into the database, you are passing the data to the database. You're not necessarily asking to see the data back. And same with an update. You are changing existing fields to an existing record. So this command does not return a list. It doesn't return anything, but in asynchronous worlds, a void is a task rather than just the word void. So this one was returning a task of IEnumerable of T, player, fixture, etc. This one just doesn't return anything. So let's just put the statement in that we need. Follows a similar pattern to before, so it should look pretty straightforward what it's doing. Using the connection that we set up on line 33, we are calling Dapper's execute asynchronous. We're passing in our SQL statement, be that a insert, update or delete. It may have some parameters to go with that, and we're just saying what command type the database should be expecting, a store procedure or a SQL text. So I'm just going to put some examples in comments of the sort of statements that this method is designed for. So for example, it would do an insert into player the fields, field 1, field 2, field 3, where the values are value 1, value 2, value 3, and that statement doesn't return anything back. It will just insert the data into the database. It would also do a delete statement. So we would pass in our web API, delete this player where their ID is 3. This is the parameter. So this parameter would go into here. Whereas on the insert, we're inserting 3 bits of information in this example I've made up, and those parameters would go again into there. And then finally an update. Update player, set, I don't know, first name equal to Fred, where ID equals 1. So this would update John Smith to Fred Smith, and it has 2 parameters, Fred and 1, and again those would go into this statement. So you can see the execute a command will always have, or almost always have, parameters, unless you're going to do a delete from player and get rid of everything, but that's probably unlikely. So those are the 2 methods that we've got. That's all we need at this stage. Let's just compile this just to make sure it all works. Okay, so that's all good. That's coming up with an error from something that I've done that we haven't shown yet, so that's fine. That's a bit of a red herring. So the next thing we want to do is we want to turn this concrete class into an interface. Now, why do we want to do that? Because we want to be coding in our best practice world with our good citizens hat on against interfaces, not implementations. This is an implementation of data access, and it is tied or coupled to using the provider that is Dapper. And if we just program our API against Dapper data access, we are completely coupled to using Dapper. It might be that at a later date we decide to move to something else, say Entity Framework or ADO.NET or NHibernate, and that would be very difficult to refactor. So we always program against interfaces, and this is very simple to achieve. All we need to do is right click on Dapper Data Access, Quick Actions and Refactors, Extract Interface. Interfaces by convention start with an I, so this will create an interface file called I Dapper Data Access, and it will stick it in the same folder as our concrete implementation Dapper Data Access. So we'll go OK, and you'll notice two things. We get a new file that is our interface, and you'll notice that Dapper Data Access implements I Dapper Data Access. And just to make this a slightly better name, I'm not going to have the word Dapper in it, because the whole point of having interface is that your application becomes loosely coupled. So we don't want to couple it necessarily whenever we're talking to a database that it must use Dapper. So the name's a bit misleading. So I'm going to rename this, pressing F2, and I'm just going to call it I Data Access. Go yes. So that has renamed that up there. We may need to go back into here. No, that's changed it as well, which is good. So we don't need to know who the vendor is that's helping us provide data access. All we need to know is that this will let us talk to a database. We don't care how we do it. We could do it in several ways, and it could be against several different databases. All we know is from this interface, if we open it up, we can do two things. We can execute a command against the database. So this is our insert, update and delete. Or the other thing we can do is we can run a query against the database, which is a select statement. And those are the two operations that we need to do against our database. That's all we need to do there. Let's do a compile again and just check everything is okay. So that's all good. And I think this is probably a good point to pause, because we've now got a data access layer in place. It's compiling. The next thing would be to see how this behaves, because at the moment we've written a lot of code, we haven't actually had any opportunity to try it out. Unfortunately, at this stage, our web API is not in a state to use this yet. So in order to mock up the use of these two methods, I'm going to create a little console application. So I'll give you 5 minutes to have a break and sort of digest what we've done, and then we can have a look at the console application and making a couple of calls to the database using our new data access layer. So we've written our data access layer using Dapper, and we've extracted it out to an interface. So that all looks good. Wouldn't it be nice just to try it out? Well, at this stage, I don't want to plug it directly into the web API, because we've got other things we need to do first, which we haven't covered in any videos yet. So in order to just give this a try out to make sure that it does speak to our database, what I've done, purely for demonstration purposes, is create a little console application called Test the Data Access Layer, and I've set it to my startup project. The other thing that I've done is, in order that this can use our data access layer, I've gone right click, no, not there, I've gone open this out, right click on dependencies, add project reference, and I've included the SMS shared class library, which holds our data access layer and also access to our data transfer objects and our models. So that class library is a nice reusable library that we can plug into anything that needs it. And in this instance, we're going to plug it into our little test harness console called testing the DAL. So that's what I've done. Then in the program CS, there'll be a lot of code, but we're not really interested in what the console does. All we're interested in is can we make calls to the database via the console application. So let's open this up and have a look at it. And what you will see is I have got several different examples just to test out if it is working or not. So up at the top, we're bringing in some using statements that point at our shared library, the DAL folder, the DTOs and the models. So like I said before, the first thing we need to do is we need to provide a connection string to our database so that our code knows how to contact the database, open up a connection, and then through that connection send various queries and commands to it. So in order to get the connection string, what we do is we open up the SQL Server panel. We go to SMS database, we right click and we go properties. And over here we get all the properties of the database. We expand this across slightly, you'll see one of these is connection string. So what I've done is I've copied this connection string out, and then I've gone into the code, and what I've done is, just because this is a demo, I've hard coded the connection string into a variable here. You can see that the connection string holds information that helps us connect. So it says what server is it on, what is the initial catalog being the database, how are we authenticating to the database, we're doing it through integrated security, and how long before we time out, and we've also got something to do with encryption and trusted certificates. But basically I've just copied that and pasted it. As it says in my comment, we won't copy and paste our connection string into our code in the finished web API, as hard coding is not a good idea. And the obvious reason for that, there's several reasons, but one is I'm on a development environment here. If I hard code my development connection string, that will be different when I move it to a different environment. And the production connection string will be completely different. And in order to change that, that would mean that I have to rebuild my code, recompile it, and send it up again. So things like connection strings that have variable information are suitable in configuration, which is what we will use in our web API. But as this is just a sort of test harness, I've just hard coded it in there for now. And then the next thing we need to do is create a new instance of our data access object, which in this case is the Dapper data access. And again, please note my comment. Again, we won't use this approach in our web API solution, as this is coupling this application to the concrete implementation. So what that's saying is this application now is always coupled or tied to using Dapper for how it does its data access. This is tightly coupled and doesn't allow you to open it for change or extensibility. There's a good saying to remember, and it's new is glue. So whenever you see new, that should raise alarm bells in your code, because as soon as you do that, you are coupling the thing that is calling that new to it, and that doesn't make it easy to change. So remember, new is glue. What we will do in our web API when we get to it is some good stuff to come in a future video, where we will program again against the idea of an interface. So rather than a new Dapper data access, we will program against an instance of iData access. and we'll be doing that all through something called dependency injection, which deserves its own video, so I'm not going to say much more about that here. But like I said before, as we're just trying to demonstrate talking to the database, this is fine in this example. So my first example that I've got here is to get all the players out of the player database. So what we will do is, first of all, we will go over to SQL and we will go to the players database and we will say view data, and we will see at the moment we have 4 records in the database. So let's see if our program will get us 4 records back. So we'll put a breakpoint on this one just to see and run it up. So we hit our breakpoint, and this is making a call to our data access layer that I've called data access, and it's calling the method in the data access called run a query. It's expecting to get a player back, and it's also provided with a dynamic, which is an object of any type, and that is the one we're going to use should this require any parameters passed into it, which for selecting all the players in this instance it doesn't need any parameters. So based on that, the arguments coming in will be the SQL statement, and the SQL statement is select star from player. Then any parameters, well, there are no parameters, so we just pass in an empty object, new curly bracket, curly bracket. We just specify what type of query we're passing. We're passing a SQL line of text, and we also pass in the connection string, which will tell the data access layer how it creates a connection to the underlying database. So if we press this one, that is come into the shared SMS library, hit the data access.cs file, and we've hit our run query. We can see the stuff that's been passed in here. So we've got our query, we've got our parameters, which is nothing in this case, our command, which is text, and our connection string, which is that funny long connection string. So if we carry on through here, we make a connection to the database. So the connection is now open to the database. And then we fire this query at the database. And then the result comes back and it gets written to players from database, which is an IEnumerable of type player. So if we have a look in here, we can see we've got 4 records, and they're the records that you would expect. And then all I'm doing then is I'm just looping through the records to put them out on the screen. So there we go. Not in a very pretty format, but we get the first name, the last name, the email, the phone number, and is active player. So that's great. That means that we're now communicating with our database using the Dapper data access layer. Let's try some other queries just to check we can do all the other things that our web API will need to do once we hook the data access layer into our web API. So I'm going to comment out example 1 and move on to example 2. So example 2 is yet another select or HTTP GET if we're talking in web API speak, and this one is just going and getting one player out the system based on an ID provided. So same sort of format as before. We've got a SQL statement, select everything from the player database where the ID equals @ID. @ID is a parameter. Here's our statement again for talking via Dapper, data access.run query, a player, pass in a dynamic, which can be our list of parameters, and then we supply it with our arguments. So we've got the SQL statement, which is here. We've got our parameters, which is just an object that has an ID in it. Again, the command type is text, and the connection string is our strange connection string at the top of the page. If we just run this one, I'm not going to put a breakpoint on this one, I'm just going to run this one. We would expect for when we pass in a suitable parameter, so let's put in 3 into the system, and 3 in our database, if we just go have a look at our database, is Ben Stokes, so that's the record we're expecting to get back. So if I hit enter, in this instance, do I get anything back? Just hit F5 again. There we go, Ben Stokes. So yeah, so that's give a good example of our get player by ID endpoint. So that's working fine. Now it would be worth trying some of the sort of commands that we do against the database. So the inserts, updates and deletes. Just testing those out. So in order to do that, I'm going to comment out example 2. And then I'm going to uncomment example 3 and just walk you through what this one does. So this one looks a little bit more complicated, but it's not really. So this one is to add a brand new player into our database. So what we're going to do on line 51 is this is a little method that creates our console user interface that will ask the user several questions like what is your first name, what's your last name, what's your email, what is your phone number. That's all that's doing. Here's the actual statement we're going to throw at the database. Insert into the player table a first name column, a last name column, an email, a phone number and an is active, and in those columns please put in these values: at first name, at last name, at email, at phone number, at is active player. So if we come and have a look at the data access call, this time we're doing a data access.execute a command, and the execute a command does not return anything because it is a command, it just issues a command against the database. So in this case it's issuing an insert command against the database. So what we're doing is we're passing in the SQL statement, this insert statement, then we're passing in our parameters. Our parameters is a new player, and we're passing in a new player object, and we're passing in each of the parameters that come back from our user input, which is done via this method here, little helper method. So the user will be prompted 1, 2, 3, 4, 5 times to provide 5 answers: first name, last name, email, phone and is active, and those all get written into this little helper object that will paste into this overall player parameter. Again we set the text, and again we pass in the connection string. And as this doesn't return anything back, I've wrapped it in a try catch. So if this all succeeds, we get a inserted new player. If anything goes wrong, it will say something went wrong with insert. So our database currently has 4 records in it, so if we run this one, hopefully we'll have 5 records in it afterwards. So let's just run this up, see what it looks like. So the first question asked the user is provide a first name, so I'm going to put in Joe, hit enter, enter a last name, and I'm going to put in root, then an email address, joe at route66.com, then a phone number, and then is the player active, and I'm going to put in true. Hit that. Let's take our console right line off, hit enter, and it says inserted new player. So that all looks good, but has it inserted a new player? Well, let's go have a look in the database to find out. So db.player, if we go in here and we just do a refresh, there we go, we've got a new player, Joe Root. And the system, the database this time, unlike our in-memory database, has sorted out the ID field. Because it is a system generated field, it's made that 6. So previously I must have put in another record and deleted it that was 5, so it's filled the gap up with the next one that it hasn't used, which is 6. Whereas before in our in-memory example we were having to write a hack round to sort this ID out. So again, this is improved our code because we don't have to worry about that anymore. So finally, back in our little test harness, I have written a final example that is using a delete statement. So let's try that one. So we just comment this out. We go to example 4 and uncomment this one. And this one is performing a delete a player. So in order to delete a player, we need to run this delete statement, delete from player, where ID equals @ID. So again, we're supplying an ID from the user. This @ syntax that we've seen in a couple of these queries is making the query parameterized, which is a good thing. And without going into too much detail, because again this isn't a SQL specific course, this stops this from SQL injection. And SQL injection can have some devastating effects on your database, because if you don't use parameterized queries, you can issue malicious statements at your SQL database that can expose information it shouldn't do, or even delete information. So parameterized queries are very important. Please go away, have a look at SQL injection attacks. So back to the data access, we're calling the execute a command again. We're passing in the SQL statement, we're passing in the parameters, in this case just an ID, which is the ID that we get from the user on this line here, line 81. Still a text statement, and we're still passing in the same connection string. Again, because it doesn't return anything back directly, I've wrapped it in a try catch. If it all works, we'll say the player has been deleted. If something goes wrong, we'll say something went wrong. So let's just try this one out. I just need to comment out this helper method as well, I think, just in case that might cause an error. And let's just spin this one up and see if we can. Oh no, we've got errors again now. Let me just put that back in. It probably won't hurt. There we go. So yeah, what we'll do is we'll try and get rid of the record for Joe Root. So Joe Root is 6. So let's just try this again. Provide player ID you wish to delete. So if I just say 6, hit enter, player has been deleted from the database. So that looks like it's all worked successfully. Let's just stop the application and refresh the database and see if Joe has disappeared. And yes, he's gone. So yeah, that's good. Our data access layer is working with all CRUD operations just as we want it to. Like I said, this particular section of the video has been just testing out our data access layer. We're not really interested in how I've implemented this console, because it's just a test harness. Yeah, so I think we're in a good position. So we're done. I said this one would be a complex one, but don't worry too much about it. Even though it includes such things as generics, asynchronous methods, and interfaces, the key takeaway is we now have a set of code that has one responsibility, and that is to talk to the database. So I'm the Hawaiian shirt coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.